Hello everyone. Now let us see the questions which appeared on diode resistances in GATE exam. The very first question is that was in 2002 marks, in year 2002 marks question. A diode whose terminal characteristics are related by this, you are given the relation where Is is the reverse saturation current and Vt is thermal voltage, that is 25 millivolt, is biased at Id equal to 2 milliampere. Your forward bias current is given. Its dynamic resistance is, you have to find the dynamic resistance of the diode. So we know the dynamic resistance of the diode is given by Rd equal to eta Vt by Id. You are given Id, you are given Vt. Eta is not mentioned here and nothing about the material is mentioned, so we will be taking it eta equal to 1. Whether you assume it germanium or if nothing is mentioned about eta, so take eta equal to 1. So here rather than saying germanium, so I will assume eta equal to 1. So I'll just make small change here in my assumption. So Rd, just by putting these values here, I get value of Id. So just I have derived the expression in the question itself just for your understanding. Otherwise that formula was to be used. Now let us see the next question. In a circuit shown below, the ideality factor eta is ideality factor of the diode is unity, eta is given to you. The voltage drop across the diode is 0.7 volt. The dynamic resistance of the diode at room temperature is approximately, you have to find the dynamic resistance. So before we go for dynamic resistance, we can find the forward bias current and that will be giving you the dynamic resistance. Fine, room temperature means 300 K. So the forward bias current of the diode is given by this, that is Id equal to 1.7 volt minus drop across the diode divided by this resistance, so this gives you 1 milliampere. The dynamic resistance of the diode R is equal to eta Vt by Id. At room temperature Vt, you know, that is thermal voltage, eta is given to you, that is ideality factor equal to 1 for germanium. So at room temperature Vt is 26 millivolt. You have to remember this point. Vt is nothing but T by 11600, that many volt. So at room temperature T is in Kelvin, that is 300 K, so you'll get 26 millivolt. So just by putting this value here in this Id you have already calculated here. So by putting the value of Id, eta and Vt in this relation, you get the dynamic resistance of the diode. So these were the only two questions which appeared from dynamic resistance of diode in GATE exam. Next topic we will discuss about the your diode capacitances. Just wait for my next video for discussion on the GATE questions on diode capacitances.